All right, we are going to be jumping into 4.8, which is triangles like on the coordinate plane. And then we're going to roll into that some factoring practice to help us prepare for our upcoming section in chapter 5. So when we are dealing with triangles on the coordinate plane, there's a few things that we're going to do. If we're creating a triangle on a coordinate plane, we're going to try to use the origin as one of our vertices or vertex, one of the corners of our triangle, so that way we know that point is always 0, 0. We are going to place at least one side, hopefully, on an axis. That gives us the flexibility and ease of either using something like a number and 0 or 0 and a number as one of our points. We're going to try to keep it in the first quadrant because then it stays positive. And we're going to try to use coordinates that make the computations or the calculations as simple as possible. So we're going to take a look at our first one here, which is triangle ABC. And if you notice, it is an isosceles triangle. And something that's important to note when you have isosceles triangles, we haven't really talked about this yet, but when you have an isosceles triangle, when you drop a line down from the top vertex at a right angle, it actually bisects the base and creates two congruent pieces. So this side and this side are equal to each other. So this could be 1 and this could be 1, and they are equal to each other. So taking a look at our triangle ABC, if I drop we call this the altitude, by the way. Again, that's something we're going to talk about in chapter 5. If I drop an altitude down, that will give me the x value of my C. And looking at A and B, A is at 0, 0 because it's at the vertex. B is at 2p. Just like previously when we had variables added into our ordered pairs, just ignore them, but make sure they make it into your final answer. So I know C is going to have a p in it. That's a part of our x value. And if we go all the way over, we're going 2p. But if we're only going halfway over from 0, 0, we're only going 1p. So our answer is 1pq. It's kind of a weird idea. I'm sorry, guys, but we'll work through it and get some practice. Our next triangle is triangle RST. It is a right isosceles triangle. It's hanging out on its side, so that right angle is kind of touching the base. We are looking for point T here. And if we go all the way over to S, that's a total of 2a steps. So that means T also went 2a steps to the right because it is located directly above S. Then we need to find out, well, how far do we go up? Well, one thing to note is that these are congruent. So however far I go from R to S is how far I'm going to have to go from S to T. And since I went 2a steps from R to S, I'm going to have to go 2a steps from S to T. Yes, I do not have to change the Y to a different letter. If we can use the letter consistently for both the X and Y values, or we might change letters. So it depends on how things are set up. So since we go 2a steps up to T, that means the Y value is 2a as well. All right, our next one, we have another isosceles triangle. So that means we are going to drop an altitude from P to that point of that altitude. If you look at the location of R, we're 2a steps over. So if I go another 2a steps over, that means my X is at 5a, or 4a, sorry. And then we have not left the x-axis, so our y value is going to be 0. It's kind of a weird looking 0. There we go. Okay, and then we have this point, or this triangle, ABC. This triangle is also a right triangle, also isosceles, but it's hanging out in a different direction. So if we look at from C to B, we travel 2a steps. So traveling from B to A, since these are isosceles triangles, should be the same number of steps. So we're also going 2a. Since we're staying on the y-axis, our x value stays 0, but our y value instead is going to be 2a this time. All right, let's see if we can create some of our very own. We have an isosceles triangle, so we know it's going to have two congruent sides, and our base is going to be on the bottom. It's going to say RS, so the top is going to be T. So we're going to start with R at the origin at 0, 0. And it says from R to S is 4a units long. So from R to S is 4a units long. So the location of S is going to be at 4a, 0. So then we need to find where T is going to be. So create the points of our triangle. And since this is isosceles, it means we're going to have an altitude that can drop down and help us figure out where T will be. Since we're only going halfway across, the x value of T is going to be at 2a. And I don't have anything specifying how far up I'm going to go, so I'm just going to use a new variable and say it's at b. So like 1b or b. So we have the points R, 0, 0, S, 4a, 0, and T at 2a, b. And our last example of this type, we have an equilateral triangle. So remember our equilateral triangle, all three of our sides are going to be congruent to each other. So Q is going to be at the vertex of 0, square root of 3b. Each of our sides are going to be 2b long. Okay, so we have a point at 0. I'm going to make some points here. Kind of guesstimate. Just look super even. Okay, so this is Q at 0, root 3b. We've got this over here. So if our side length is 2b units long, and Q is right on the y-axis, then that's going to be hitting right at our midpoint. And so I'm going to say that's Q, so E and I is going to be sitting at positive b or 1b, 0. And E is going to be hanging out at negative b or negative 1b, 0. So we have our equilateral triangle. Each one of these sides are congruent to each other. So this is 2a long. These would also, EQ and QI would also be 2a long.